Welcome to Geometry, Unit 9, Section 3, Arcs and Chords. Arcs and chords and zombie hordes. Oh my. Okay, so arcs and chords. A chord is a segment with its endpoints on a circle. If the chord is not a diameter, then its endpoints divide the circle into a major arc and a minor arc. So we can look here. This chord FG divides, we have arc FG as the minor arc for that, and we have the major arc being arc FJG. In the same circle, or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So arc FG is congruent to arc HJ, if and only if segment FG is congruent to segment HJ. Okay, so let's do some absolutely awesome congruent arc example problems at this time. Okay, so we have an embroidery hoop, and segment AB is congruent to segment CD. The measure of arc AB is 60 degrees. What would be the measure of arc CD? Well, since AB is congruent to CD, right? Since this is true, then arc AB is congruent to arc CD. So if the measure of arc AB is equal to 60, then that's true for the measure of arc CD. So the measure of arc CD is 60. Okay, in these two figures, circle J is congruent to circle K, and arc MN is congruent to arc PQ. So we want to find the measurement of PQ. Well, since those two arcs are congruent, these two segments are congruent. And that being the case, then we would set up the equation as 3x minus 7 is equal to 2x plus 1. Subtract 2x from each side. So I get x minus 7 equals 1. Add 7 to each side. X is equal to 8. Well, if x is equal to 8 and PQ is equal to, so PQ is equal to 3 times x, which is 8 minus 7. So 3 times 8 is 24 minus 7. So PQ is equal to 17. Okay, in circle W, arc RS is congruent to arc TV. Find the measure of RS. Again, since the two arcs are congruent, these two segments are then congruent. So that means our equation would be 5x minus 9 equals 2x plus 3. Subtract 2x from each side. I get 3x minus 9 equals 3. I'm going to add 9 to each side. 3x equals 12. Divide each of these by 3, and x is equal to 4. So we want to find the length of RS. So RS would be 5x minus 9. So that's 5 times 4 minus 9. So that's 20 minus 9. So RS is equal to 11. Okay, so if a line, segment, or ray divides an arc into two congruent arcs, then it bisects the arc. Okay, so if a diameter or radius of a circle is perpendicular to a chord, it bisects the chord and its arc. So basically what this does, it would cut these two into congruent pieces, and this little section here would be congruent to this little section there on the arc. Okay, if we take this logic in the other direction, if a segment is perpendicular to a chord and also bisects the chord and the arc, then it is a diameter of the circle. So if segment AB is a perpendicular bisector of chord segment XY, then segment AB is a diameter of circle C. So now let's do some absolutely awesome radius diameter perpendicular to a chord example problems. All right, so in circle S, the measure of arc PQR is 98. What is the measure of arc PQ? Well, since this is bisecting, right? Right? So these two are bisecting. This radius is perpendicular to this chord. That means it is bisecting these two pieces. And since it's bisecting these, then these two are congruent, which means they're each half, right? It cuts this big arc in half. So if the measure of arc PQR equals 98, then half of that would be the measure of arc PQ, which would be 49. Okay, so in circle R, find TV, round to the nearest hundredth. So this problem is a little more difficult. So what we're going to do here is, first of all, we're going to find this length right here, right? Because it's a radius. So the length of this radius is 11, right? So UR is equal to 11. So if UR equals 11, all the radii of a circle are the same. This distance here is 11. So because I have a right angle right here, this is a right angle right here, I have a right triangle now. So I know this is the hypotenuse, 11 is the hypotenuse. So 6 squared, right? So SV squared plus 6 squared equals 11 squared. So SV squared plus 36 equals 121. So I subtract 36 from each side, and SV squared is equal to 121 minus 36, which is 85. So since we're going to round things to the nearest hundredth, SV is equal to the square root of 85. So I take my handy dandy calculator, which I can't show on this video because of the way things are. So, but that comes out to 9.219, right? So we'll say 9.219. So we also now know that since this is perpendicular, the radius is perpendicular to this chord, that this segment here is congruent to this segment here. So TV is going to equal 2SV. So we're going to double TV. So TV, so we're going to multiply this times 2. And I've got 18.439. So this would round up to 18.44. Okay. In the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So FG is congruent to JH if and only if LX is equal to LY. So this must be congruent to this in order for FG to be congruent to JH. So now let's do some absolutely awesome chords equidistant from the center example problems. Okay, so in circle A, WX equals XY equals 22. Okay, so this equals this, and those are 20, each 22. Find AB. Well, if that's true, then this segment here is congruent to this one here. So we can set up our equation. 5x equals 3x plus 4. Subtract 3x from each side. I get 2x equals 4, divide each side by 2. X equals 2. So if x equals 2, AB is equal to, AB is equal to 5 times 2. So AB equals 10.